Okay, now we're going to look at examples of geometric sequences, both explicit and recursive formulas, and geometric series. So for geometric sequence, for the explicit formula, well, the key thing to remember for a sequence is you need to find the common ratio. Not the difference this time, but the common ratio, where you divide the second term by the first term and the third term by the second term and so forth to make sure that the ratios are in common. All right, so once you do that, what you need to know is whatever term in the sequence that you're looking for, all you need to know is the first term in the sequence, the common ratio, and the number of terms, the total number of terms that you're looking for. So let's do an example right here. So here we have 1, 4, 16, 64, 256. And if we look at the common ratio where we divide the second by the first, 4 divided by 1 is 4. The third by the second, 16 divided by 4 is 4. 64 divided by 16 is 4, 256. They all share the common ratio that is 4. Well, a to the first is just 1, and there's 1, 2, 3, 4, there's 5 terms. But what if we want to find the 10th term? Well, that's the first term, a sub 1, which is 1, times the common ratio, which in this case is 4, and then it's 4 is raised to n subtract 1. Well, in this case, we're looking for 10, so 10 subtract 1, 4 to the 9th. So let's come over here, and when we do that, we have a to the 10th is equal to 1 times 4 to the 9th, which gives us, and you just type in your calculator, 4 to the 9th, raised to the 9th power, times 1 is 262, 144. And we're going to keep a hold of that, and then we're going to talk about recursive. So recursive formulas, remember, are based on previous information. So if I wanted to find the 11th term, I could just take, well, 11 subtract 1, the 10th term, and multiply it by the common ratio. And that's what I'll do here. So if we want to find the 11th term, so a sub 11 is equal to a sub 10, which was 262,144. Multiply that by the common ratio, which is 4. So you take that number in your calculator, multiply that by 4, and you end up with the 11th term, and that's using the recursive formula. So 1,048,576. Okay, so the explicit formula tells us that we need to know the number of terms, the first term, and the common ratio. The recursive formula tells us all we need to know is the previous term times the common ratio. All right, now let's look at geometric series. And remember, it's the sum of each term in the sequence. And this is what you need to know. You need to know the first term. You need to know the number of terms in your sequence, and you need to find the common ratio. So if we go back here, there's 1, 2, 3, 4, 5 terms, and if we do the sum, and the first term is 1, the common ratio is 4. So if we plug everything into this formula, I'll do it here down below. So the sum of the first 5 terms in that sequence that we were doing, well, the first term was 1. 1 subtract, the common ratio was 4. N is the number of terms, so 5 terms, all divided by 1 subtract the common ratio. Let's see. So 4 to the 5th is 1,024. 1 subtract 1,024 is going to be negative 1,024. 1023 times 1 is still negative 1023. Divide by 1 subtract 4, which is negative 3, and you will end up with, so negative 1023 divide by negative 3, 341. And if you think you might have made a mistake or you're not quite sure, you could actually go back here. Here's a cool thing about geometric sequences. Oh, I'm sorry. Just add up the numbers. So 64 and 256, what do you end up with? You end up with 320 plus 16 is 336. Well, 4 plus 1 is 5. So that doesn't take very much time when there's just 5 terms. But what if there's 25 terms? Or what if there's 100 terms? This is a much simpler method. Then the only other thing that I want to cover with you is in the instance of infinite series. Infinite series happens sometimes, but the only time we can have an infinite series is when the common ratio, the absolute value of the common ratio is 1. So the common ratio could be negative 1/2, but the absolute value of negative 1/2 is positive, and 1/2 is less than 1. And then here's the formula for that. It's just the first term divided by 1 subtract the common ratio. So here's an example of that. Whoops. Here we go. And the dots indicate it's going to go on forever. Well, first we have to find the common ratio. Well, 64 divided by 128, you get 1/2. 32 is half of 64. 16 is half. Okay, so our common ratio is 1/2, which is less than 1. So that's good. Our first term is 128. And look at, that's all we need to know. So we're going to put the first term, which is 128, divide by this quantity, 1 subtract the common ratio, which is 1/2. If we simplify that, we have 128. Well, 1 subtract 1/2, well, we could rewrite 1 as 2 over 2. 2 over 2 subtract 1 over 2 is 1 over 2. And then if we multiply top and bottom by the reciprocal, so all of those terms added together is equal to 256. And very simply done. Okay, that's it.